So here's definitions you can copy down for today. So vertical line test, you might have learned this before. It always kind of varies where it goes. But it's basically you take your graph, whatever it may be, and you look, can I draw a vertical line through that graph anywhere on it and hit more than 1 point of the graph? If I can only ever hit 1 point, it's a function. If I can find a spot where I hit more than 1 point, it's not a function. So like if I had a circle-ish, I can hit 2 points, so that's not a function. So function, I think on the last slide I had this, just means for every x value, there's exactly one y value. Or for every domain value, there's exactly one range value. Okay. We talk about domain and range, what's called set notation. So that's where we can write a large set of numbers in a very condensed way. It's similar to inequalities, where like x is greater than or equal to 2. That's every number of 2 and greater than 2, right? So we can write a whole bunch of numbers with that simple notation. Same thing here. So if you think about a number line, filled in circle, that is greater than or equal to, right? Mm-hmm. That would be the same as brackets. Brackets means you can be at the number or anything to the whatever side of the number, depending on what you're looking at. Parentheses means you don't include it, so that would be the open circle, which is just the inequality. And then union is how you put more than one of these things together. So f of x equals 2x. Example, I just put like example 1 in your notes, so you can always refer back to it if you need to. You don't need to write all this stuff out. Um, 2x would look like it's a line. Basically, the only thing that ever affects the domain is if you have a variable in the denominator, or if you have are taking a square root of a variable, because then you have values that you can't have. Like if x is in the denominator, if you have 4 over x, what can x not equal there? What can you never have in the denominator?
0.
Mm-hmm. So x cannot equal 0 for that example. Mm-hmm. If we had square root of x, what can we not take the square root of?
0.
Good guess. But 0 times 0 is 0, so the square root would be 0. Negative numbers. Makes it where you can't do it. Okay, so those are the only two things that ever affect the domain. So for this one, domain's all real numbers. How we would write that is parenthesis negative infinity, comma, infinity. That means we start at negative infinity, so the smallest number you could think of, and it's smaller than that. And then any number from that all the way up to positive infinity. Basically, there's no number you can't plug in for x. Range, same thing for this one here. There's no y value that would not show up on the graph. Absolute value of x, that's a V shape that looks like this. That would be a function. Domain here, there's no missing x value, so it would again be negative infinity to infinity. The range, so that means we're looking at the y values from here to here. But we notice all of these y values down here are not included, right? So the smallest y value we have is 0, and you can plug 0 in, so it would be a bracket. And it increases all the way up to positive infinity. Yeah?
Yep.
Okay. This is what we call a piecewise function. So these I'm just sketching, I'm not actually graphing. But for where x is less than or equal to 0, it's -1. For when x is greater than 0, it's 2. So there is a jump here, but because we have a filled in circle here, where there's an open circle up here, there's still a value there at x equals 0. So domain would still be our -infinity to infinity. Our range is a little bit different here. -1 or 2. There's only 2 values. Sometimes you'll see some people write like this, where it's the squiggly bracket, -1, comma 2, squiggly bracket. So we talked about this earlier. We know that x cannot equal 0. So this graph looks like this. Our domain, so for x values all the way over here, this line is going towards it, right? So that means we've got -infinity, and then it approaches 0, but it doesn't cross 0, so it would be to 0. And then we can't be at 0, so we put a parenthesis. So it means we can get really, really, really close to 0, but never touch 0. And then union, then we can start at 0 again, and then go towards infinity. Again, that would be a function, because there's no value where there's more than one y value for the x. Every x has one y value. Last thing here, you'll have to evaluate some stuff. So just a reminder on function notation. If you have f of x equals, just making this up, x squared plus 5x minus 4, and then it might say for x equals 3. How you would show that is you plug 3 in for x, so that means wherever you see an x, you plug a 3 in, you get 9 plus 15 minus 4, which would be 20. So f of 3 would equal 20.